Okay, it says graph the feasible region for the following system of inequalities by drawing a polygon around the region. So I'm actually just going to graph the lines on here, and then even though I'll show you at the end how you would just graph the polygon. So I'm going to graph this first line in this like bluish gray. I'll graph the second in this maroon color. And then the x is greater than or equal to 0, y is greater than or equal to 0, just means that we're going to be in the first quadrant. We're going to be this side and this side of the origin. So since this is written in standard form, I'm going to graph it using intercepts. So if I want to find the y-intercept, that's what I'm going to get when I let x be 0. So I get 0 plus 6y equals 30. Solving for y, I get y equals 5. So my y-intercept is 0, 5. And now I'll do the x-intercept. That's what I get when y is 0. So if I plug in 0 for y, I get x plus 6 times 0 equals 30, or x equals 30. Okay, the second one. Oh, before I do that, I'm going to test 0, 0 to see which side the shade. Test 0, 0. Plug in 0 for x and 0 for y. I get 0 is less than or equal to 30, which is a true statement. So 0, 0 works. So when I graph this, I'm going to shade towards the origin. Now, 0, 5 is right here. And then 30, 0. 30, 0 is going to be somewhere, boom, like way out here. Okay, we're just going to eyeball it just to try and figure out like what we're going to do at the end. So it doesn't have to be perfect. I'm sure it's not perfect the way I drew it. Connect those. And then I'm going to shade towards the origin. So I'll shade down like this. I'm not going to shade in just yet, just to make it a little bit neater on my graph. Now let's do the second line. It's also in standard form, so I'm going to graph using intercepts. The y-intercept, that's what I get when x is 0. So if I plug in 0 for x, I get 4y equals 40, or y equals 10. And then you should see that since x and y have the same coefficient, that the x-intercept is just going to be flipped. This is going to be 10, 0. And 0, 0 also works, so I'm going to shade towards the origin here. So I'm going to connect 10, 0 and 0, 10, like so. That's good enough. And shade towards the origin. So my feasible region is going to be, let's do this in, we'll make it bright pink, is going to be from this intersection point down to here, from 10, 0 to the origin, up to 0, 5, and then back to that intersection. So I have these three vertices. This is 0, 5. This is 10, 10, 0. And this is 0, 0. I have to figure out what that coordinate is. But that's the point where these two lines intersect. So all I have to do is figure out where these equations, x plus 6y equals 30, I don't care about the inequality anymore, and 4x plus 4y equals 40. Solve that system, and that'll give you this coordinate. So I'm going to run through this kind of quick. I'm just going to multiply the first equation by -4. So I'll write that actually underneath. I'm going to distribute that to everything. So I get -4x. -4 times 6y is -24y. -4 times 30 is -120. Adding the second and third equation together, the 4x's cross out. That's what I wanted. I have 4y minus 24y is -20y equals 40 plus -120 is -80. Solving for y, we get y equals 4, which, I mean, our graph is pretty good, right? Y equals 4. Now to get x, I'm just going to plug 4 back into either equation. I'll plug it back into the first one. X plus 6y. X plus 24 equals 30. X plus 24 equals 30. So x is going to be 6. I didn't even know the answer, and look how close we were. That's where they should have intersected. So this is the polygon we're going to graph. 0, 0, 0, 5, 6, 4, 10, 0. Just to show you what that looks like. 0, 0, boom. 0, 5, 6, 4, 10, 0, back to. There you go. And that's going to be your answer.